Welcome back, ladies and gentlemen. I hope you've enjoyed your tea, coffee, fruit break. A little bit unusual. I've asked for a couple of chairs to come in for a couple of people who are standing at the back. I don't quite know how to do this. Do I say I have great pleasure introducing myself? Do you? I really don't know if I do or not. However, I'm very proudly standing here today as the newly elected Vice President of the Institute of Sound and Communication Engineers. I'd like to thank you all for that honour. Thank you very much. It's also a real honour to be giving today the Warren Barnett Memorial Lecture. Ros sends her apologies because she has, in her haste of organising everything she's organised for this conference, neglected to bring the photographs that we normally have of Hayden, Warren and Peter Barnett sitting on the side. So apologies that that's not here this year. I'm sure it'll be here next year. She won't forget again. The title of my lecture is ANS, A New Solution, which is a bit of a play on words along the title of ambient noise sensing, or the technology that we call ambient noise sensing. And this is looking specifically at a case study of a specific project in the rail environment where there's a noise-sensitive site. And as we go through it, you'll learn to appreciate that the PA system was deemed to be creating a noise nuisance for the residents. So that's what I'm going to talk about. It is a case study, and this system is now installed and working in anger and has been for 6 months. It's not a premature presentation of a case study. It is real. I'm going to talk about the problems of the site, because as I started to write this, I thought without the background story, you really don't understand what has been achieved. So we'll talk about the problems, and then the design process itself, which was very intense, and that will become clear. Because the project has spanned decades. We were waiting for the technology to catch up to provide a solution effectively. It's also very apt to be giving this as the Warren Barnett Memorial Lecture, because when we first started looking at this problem, I was working for Peter Barnett, and he was very much involved in the first early stages of this. So, Pete, I hope you like what we've done. Let's find out. And the other thing to say is, literally, it has been decades. It's almost 20 years. And Tony Stacey, my colleague, and I are really hoping this is the end of this project, because I'm sure everybody, every practitioner has had one of those projects that you always think, oh, it wasn't quite the right solution, and if only we could have just gone that extra little bit more. And we're hoping that we finally put this one to bed and we don't have to spend another 17, 18 years worrying about this one. So what are the problems? Well, back in the year 2000, a new PAVA system was installed on this site that shall remain nameless, but some of you will probably recognise as I go through some of the graphics. And a new PA system was installed. It was quieter than the PA system that it replaced, but it was more intelligible. And this meant that residents were actually hearing messages, which obviously is much more disturbing and distracting than just hearing a few horns sort of bleating in the background somewhere. And we're trying to balance, obviously, requirements for intelligibility on the site for the client, and then these external issues, any problems that may cause. The residents eventually convinced the council to take the client to court, and the system was finally deemed to be a nuisance and is the subject of court order, an abatement notice. And the PA system is effectively, in terms of the site, turned off. It's so quiet that it may as well not be there. It's more of an irritant. It's a little bit like having a wasp flying around your ear. And this is a major London interchange station, and it's prone to overcrowding. And operationally, they rely on the PA to communicate on these regular days, but also on really busy days too, for rush hour passenger management and crowd control. So we have this noise nuisance issue and a court order, which, in order to not subject the residents to nuisance is effectively useless. We're physically very close to the residents themselves. Add to that a very weak physical structure and the fact that it's a listed heritage site. You can start to see the conundrum that we're trying to deal with. If you can't, let me explain a little bit more. So we've got neighbours. Everybody needs good neighbours. And so here we have the station, and this area here is enclosed with a roof. And then we have what we call a station cut, which is open, and it's actually lower than street level, where trains literally come to the outside. We have residents here, and you can see what kind of residents we have, and here, and then here, and also here. And you can see we're in a very nice area of London at this point. Add to that a leaky roof. So we have this lovely listed Grade 2 architectural and historical interest. And what we're then looking at here is understanding that this shed was built for steam trains. So as well as having these lovely physical holes, weak glass structure, we've got physical holes in between here. It's basically just a simple rain canopy. There's overlapping, but air comes in and goes out because, of course, they were trying to dissipate steam. And that's one of the things that we can't change. And being an original structure from the late 1800s is very weak by current standards. There's not a lot you can do with it. You can't bulk it up or change it particularly. And very thin glass. And then we have a huge hole at the end because, of course, it goes down into this canopied station cut area. So, as we all know, sound loves going through holes. Add to that a party wall, a single skin bricked party wall, and then you have to start worrying about all sorts of other things. Literally, these mews houses are on the station wall. That's where they are. I've mentioned we have a station cut there. And so you can see this is the station cut. There's a little clue as to where we might be. These are canopies, and here are some trains sitting on the platform. And this up here is street level. So those are our holes. So as I said before, I'll say it again, effectively this PA system is now off because the noise nuisance abatement notice says the PA must not exceed 60 dBA at the residence facades. And the time measurement of that is an LAEQ 10 seconds. So they're trying to catch really transient events that might cause that. We have no intelligibility then as to meet that notice on the platforms or indeed other parts of the station. And the client, London Underground, have marketing and planning standards. They not only have life safety standards for voice alarm, they also have public address standards that require that they give good customer information. And the problem that gives them is in this day of KPIs that we all have to meet these days, intelligible public address announcement and customer information is one of their key KPIs, and they have these mystery shoppers wandering around their sites, and their performance is scored on how well that PA is understood, and whether it's clear, whether it sounds nice, which is always an interesting thing to try and measure what sounds nice, but we have to try. So this is obviously causing a major problem. So a new project started. This never really finished after the system went in at 2000 because it sort of rolled forward, and eventually a new project was started with the following goals. We had to have compliance with all of the London Underground standards for both voice alarm and public address, the removal of the court notice, achieve 0.5 STI for voice alarm, 0.5 STI for regular passenger announcements and customer information, and have a solid best practicable means defence in the event that there's a challenge in the future. So we're straying here from electroacoustics and acoustics into law, which is always very interesting. We were only able to do this because of the legal aspect this whole project came about. Because the sheer amount of resources required to undertake the studies that I'm going to take you through are enormous and completely out of kilter with something that would normally be carried out on a railway station. It literally went to director level of TfL to get the funding to do this project in times of austerity. And that's a fairly big burden to carry. You're starting the project not knowing if you've got a solution, but everybody's put faith in you that something will happen and it will be better and they will have intelligible PA. They won't be annoying the neighbours. And so this is an interesting project. Interestingly enough, we were told that when we're looking at the PA announcements, we should assume that there's a message every 30 seconds. And we were like, every 30 seconds? That's a really long time, really short time between messages. Really, is that what's happening? Okay, well, we'll find out. So the scope of the project, we ended up, I'm sure everybody has these clients and they have engineers within their teams, but they're not real specialists and they don't even know how to start the project. So it was left to a group of us to work out what should be done, how we could do it and achieve all the project goals. And this is the scope that we ultimately came up with. We needed to do a feasibility study, which I will talk about, that shows all of the options for resolving this issue and meeting all the project goals, regardless of pragmatism, regardless of any cost. It was a purely engineering exercise. We then had to undertake an operational review because, I'll be honest, I was sceptical about every 30 seconds the PA being used. Let's find out how they're using it. There were also very strict terms under the abatement notice as to how the PA was allowed to be used, what times it was allowed to be used between, what it was allowed to be used for. And whilst the client had all these guidelines, had their staff trained, we needed to evidence the fact that that was being carried out in order to stand on firm ground and say, yeah, that is what is happening. So there's an operational review that I'll talk about. And then we come on to the system design. Now, last week, when Ros was frantically emailing all of the presenters, asking them if they had done their presentations yet, I just wrote, no, I'm terribly sorry, I haven't got time. Could you help me, please? Could you do it? So she did, and she sent me some slides, and I've included them because they're quite good fun. She wrote waffle, 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 and that's probably what I'm going to do. And I just thought, well, that's a funny picture. I've been collecting these things for years. Have a look. So there'll be the odd slide, hopefully to break this up a bit, courtesy of the Secretariat. Feasibility study. So we have two lines of attack for our feasibility study. We have to look at acoustics, and then we have to look at system electroacoustics. It's often so underrated how much acoustics plays a part in all of this, and people think there's system magic or loudspeaker magic, amplifier magic, microphone magic. You've got to go back to the acoustics every time and see if you can do anything with that. And in this study, we looked at everything from the sublime to the ridiculous, as you will see, just to try and show we had looked at absolutely everything. And this process took way over a year to go through it. And we not only looked at existing options, we looked at conceptual options as well for things that you may be able to develop in the future. The outcome of that was kind of interesting. And probably a bit obvious as well, which is there isn't one solution that's able to solve all of the problems. Nothing can satisfy all of the project goals. It kind of needed to be a combination solution in an ideal world. So remember, with the feasibility study, we're not looking at reality at all. So the acoustic options that we studied were that weak leaky roof that's grade 2 listed. Well, let's get rid of it and let's put on there a proper roof that we can have some acoustic reliability from. But ultimately, that did fall over because it is grade 2 listed and they have to retain it. We talked about putting a cover roof over that roof so that you could retain it in the interior, and that didn't go down very well either. That's what I'm saying. You look at everything in the feasibility, but then there has to be a pragmatic look from the client's side, and that was not deemed to be financially achievable. We looked at closing the station cut by having a deck extension. If any of you have been to St Pancras, there's a modern deck extension there that's really funky and is acoustic in its properties. And we thought, well, there we have a working precedent. That is a good thing to do. We could achieve that here. But again, that was deemed not to be financially viable at the end of the day. We looked at noise barriers. And this is great fun, and I've got a picture for you in a minute from a model showing that. And we not only looked at typical acoustic noise barriers such as you find at a roadside or around a factory, we also looked at active noise barriers which were being bandied around as a possibility. It was very sad to discover that active noise barriers aren't quite what they purport to be. They're not a real product yet, and so the client didn't really have the stomach to develop something for this project. And the idea is kind of like noise cancellation. You put microphones on one side of your barrier, you have loudspeakers on the other side, and you try and cancel out what's getting over there. Which will be great at certain points. Other points, probably not so good. So we discounted that one. But the noise barrier, we did look at quite seriously. And it's wonderful. So here's the station cut, and you can see the canopies here, and then we have a little outside area, and then we come up to street level. And this is the mansion block. And we've got transmission paths here and here, and a 25-metre barrier in order to shield the residents. And we were trying, like, well, okay, guys, that's what it needs to be, 25 metres, all the calcs show that. Can it be transparent? Yes, it could be transparent. We still don't think the neighbours will like it. And the neighbours that we're trying to shield are this side. By the time we've put a barrier up there, we've kind of got to put one here because we're throwing it all back the other way. And there are some residents and some factories over here that don't complain at the moment, and they'll start complaining. So we need 2 thudding great barriers at this point. And if you're trying to enjoy your leafy suburban garden, you might not want to be looking at that. It solves one problem. What we always say about sound is, it's very abstract. Our job is so difficult because when people can see something, it's really easy for them to gain an understanding. And I had a little thought in my mind that this would ultimately just draw their attention to the fact there was a problem because they could physically see this thing that had to stop it. So it might not help, particularly in some regards. Electroacoustic options. We looked at everything that was available on the market and everything that was threatened to be available as well. We looked at highly directional audio, and I'm talking about DSP-controlled steerable, not just line arrays. We were looking at plane arrays. So we could not only get a vertical steer, we could also get a horizontal steer. That was interesting. Ultimately, again, the interior of this station is listed. There are remarkably few mounting opportunities. And with our weak roof, we can't hang anything from the roof. We can't impede passenger flow by having a pole with something on it. We're really struggling, although ultimately we've had to have some kind of poles. There really was no opportunity for mounting that high enough. Hypersonic audio. Wow, those crazy guys, I don't know if you've heard them, where you stand quite near the speaker and you have to sort of get under it to hear it, and they promise you that you'll only hear within a certain radius. They use them in museums and things. Some manufacturers have stopped actually manufacturing those, but there are still some brave soldiers out there trying to do it. It was interesting. It has a few downsides. One is that as soon as it's deconvolved for the first time by hitting a surface, it's the same as regular audio. So you don't really gain anything in terms of containing the audio. The second thing is, and I said earlier that the PA system was a bit like a wasp because it was so quiet. These things really are like wasps. You can hear the carrier signal when you stand under them if you have sufficient hearing. And my hearing isn't great, but I could hear it. I was like, what is that? And we were demonstrating all of this outside in the summer. And I was like, there's a wasp around me. And it was the hypersonic carrier signals. So we need to, I thought that's not going to be a viable solution in the long run. Then intelligent zoning, and I'll talk a little bit more about this. The client currently operates across their network, paging, where every single loudspeaker fires off within a zone. And they're following the old BS 7443 rule of always and everywhere. You used to have to get, didn't we, Pete? 0.5 STI always and everywhere. Right? And this is a legacy. Now, within a big institution, such as the railways, the cogs turn very slowly to new ideas. And they just wanted, no, it's got to be everywhere. And we were like, well, you know, we're really struggling. And part of the reason we're struggling is because we're trying to fire everything up. We've got so much acoustic energy that we're trying not to get over there, but we want it all here. And what can we do about that? We did manage to convince one chief engineer that perhaps by having smaller zones and dedicated areas to listen, that we would achieve the project goals. And we carried that forward. And it is part of the final solution. I said I looked at the sublime to the ridiculous. We even looked at active cancellation at the residence. And we had exciters, theoretically, on window panes, and microphones outside. Just to prove we've looked at everything we could think of, we've given it a go. And ultimately, obviously that's crazy because nobody wants to look at their window and there's this thing stuck on it from the outside trying to cancel what's coming in from the station. And these mansion blocks are quite high. They're not obviously as high as the noise barrier, but they're not far off it. Ultimately, it's unmaintainable for the client. They can't go up ladders and make sure these exciters are working, and it was a wacky idea. So that's not something that went forward. And this idea of real-time ambient noise sensing, that you could control the audio at source using microphones and intelligent DSP. Now, ambient noise sensing has been around for a while, and in voice alarm systems, it's always been a very simple effort of looking at voltages and then comparing them and then changing. It never really quite made decibel land. Also, decisions had to be made on these simple systems as to how they ramped up and down, and they inevitably were using steps. And that meant that they may not be quick enough in some scenarios to react in the kind of time we need. Bearing in mind, we've got a 10-second LAEQ that we've got to respond to. That might not be a good idea. However, at the time we started looking at all this stuff, people were talking about genuine real-time ambient noise sensing being available. It wasn't at the time in 2000. It wasn't actually even 5 years after that really available. But it was starting to become a reality. And all of these options were demonstrated physically to the client in some form or another. Thank you, Ros. That's what she thinks of me. So let's have some more gibberish and twaddle. Let's talk about the operational review. I sat on a platform from 5:30 in the morning till almost 10 o'clock at night with a camping chair, a tripod, and I thought, I'm going to get every single one of these. And the sound level meter was obviously calibrated, it was recording in real time, and I was frantically writing down every time a message was made. That was really tricky to do, because this idea of every 30 seconds they were making an announcement that was so incredulous to me turned out to be not far off from the truth. In fact, they were underestimating it. Over the broadcast day, and they were, in fairness to them, only broadcasting within the times allowed within the notice, from 7 a.m. till 8:30 at night, 840 PA messages. No wonder these systems get hot and dusty. There's some stats there on message length, and you can see they're kind of all over the show. Quite what they have to say that takes 35 seconds. I could go back to my notes and tell you exactly what it was, but obviously most of it after the first 12 seconds was completely unintelligible. And then the sources, and what we can see there is that, let me explain some client speak. We have clients that love acronyms, don't we? No more than this one, and this one has multiple acronyms for the same 3 letters. It's very distressing. DVA, digital voice announcer, that's what you would expect to see on a station, something you can schedule messages into, type messages into, record on a scratch pad. And then SAPs, station announcement points, and those are dirty old fist mics on the platforms that they can grab and just talk to. And what we did see was they were using those in peak time, and we had noted that it was those that were getting most complaints for being quite disturbing when we looked at this previously. So we can see what's going on in the station. The downside of that was this lovely project manager for the client who thought that, poor Helen, she's sitting out on that platform all day long. I know she likes tea. It kept bringing me tea. And I was like, you've got to stop bringing me tea because I can't move. Niagara Falls, that's all I'm saying. Right. So what did we find in this operational view? Well, rush hour is actually 3 hours at this multiple interchange site, which is quite a long time. The platform announcements are necessary because what I'd done, I wanted to pick what I could see to be the worst time to do this. And I did this survey on the day that the local football team were playing at home as well. And the fans started arriving at midday, having a lovely time. People were kicking footballs up and down the platforms. I was like, well, no wonder they need to make so many announcements. These people are crazy. So I think I really did get the worst case that station suffers. And at rush hour, without the football crowds, it was frightening. Absolutely frightening. People are so, the regular users know exactly where they're going. They don't see anything. And the amount of people that try to walk through my tripod because they know what carriage they're getting off and they know where they've got to go, and they're just like, you're like, whoa! And I'd rope myself off and they went, no, I'm going. And this was interesting because what I realised is those people aren't listening to PA messages. They are so trained and focused on what they're doing. They don't need the PA, so it was a good argument to back up, well, why are we doing it always and everywhere? These guys don't need it. Tourists, huge amounts of tourists on there, of course, sitting duck on the platform in a hi-fi, where's the train to this, where's the train to that? I'm really sorry, I haven't got a clue. Look at the board, maybe then. They do require to make a lot of customer information just from the sheer amount of tourists that they have there. A lovely Australian lady said, how long is it going to take me to get to Heathrow? I have no idea, but you better go, probably. The variation of the live announcements I found was huge. And I've already said 35-second message, what are they saying? But I've given an example at the bottom there. This is the same message, really, and I called it yellow line. 4 different variants that were happening during rush hour. There's a train approaching, please stand back. Ladies and gentlemen, please stand behind the yellow line for your own safety. Stand behind the yellow line and stand back. Okay. And probably the most effective one of those is probably the stand back in the reverberation time that we're dealing with. But obviously it doesn't meet the marketing and planning politeness standards. We're supposed to start everything with ladies and gentlemen and completely mask everything that comes after it so they don't know what the message is anyway, but they know you're polite. So, non-standard content, not great. The other thing I discovered is that talker proficiency, that's the very posh word for how well people speak in it, is very, very varied. There was a wonderful lady, she was very, diligently making her announcements in the afternoon rush hour. And she had to say the next train is to Wimbledon, and she constantly said Wimbledon. I think she was Spanish and she was absolute superstar, but I was like, that's not helping these tourists because, or maybe it is, maybe it's just not helping the Brits, I don't know. We also had this guy who took that microphone. I think he was a frustrated actor. And everything started with, police. And I'm like, oh, now we can't hear a thing you're going to say. He was on stage as far as he was concerned, and that's not very helpful. So what did we recommend from that? Well, obviously, standardise your content, your quality, and the delivery of your messages. Shorten your messages, optimise them so that there's actually the bit you want to get across is getting across. Increase how loud your messages are so that they're intelligible, because at the moment they were far too quiet and most of them were hopeless apart from shouting down the mic, stand back. And determine if they're all actually essential or not on a site with an abatement notice, because there were an awful lot going on. How did this inform the design? Well, we were able to take this chief engineer's a little bit of interest in not broadcasting everywhere, add into it the fact that the commuters aren't listening out for PA anyway, and get the concept of listening areas, and they became known on the project as PA hotspots. Okay. We actually went to the extent of suggesting to them they could actually mark this on the floor where this is if they wanted. That's perfectly doable. And they were like, no, that's a bit step too far, but yeah, we'll look at where we're going to have these hotspots, and I will tell you about those. And don't underestimate that that's a quantum shift in philosophy for this client. It's huge for them to accept that they're not going to just broadcast everything everywhere. And then, look, having identified the requirement for a standardised message, we've got to find a way to deliver that. And I said there were these dirty SAP, station announcement point, fist mics. Well, they still have those. They're slightly nicer now. They're much posher radio mics that they can walk around with that sound better than a fist mic. But also on the box that those are linked to, we have buttons with pre-recorded messages on for the yellow line, for the Wimbledon train, and they can just stand there and press the buttons. And if they really need to shout, stand back, they can. And operationally, that again is a big thing for the client to have to introduce. It requires a lot of training, and they're trying to get rid of decades and decades of this is how you do it through to their guys, but they've done it. That's one of Rosie's slides too. I'm drinking Diet Coke. I'm not as strong as Jamie is when it comes to my choice of lecture drink. I found this on the internet and thought it was absolutely blinding. Hey, the people are getting what they want though, so what's wrong with that? Probably not a lot. So let's talk about the system design goals. More client jargon, sorry. We had to renew the equipment to be fair for 10, which means it's got to be reliable and in service and maintainable for 10 years. That's all that fair for 10 means. We have to provide compliant VA to EN54, which obviously didn't exist when we did this in 2000. Has to be to EN54. Will not deviate from that. And I know in other market sectors, reasonable arguments are made to not do that and to use a kit system that deviates from the requirements of those standards. But in this particular project, this client will not deviate from that requirement. They deem themselves too much at risk at that point. Provide compliant PA messages, 0.5 STI, and introduce the hotspots. At this point, you know, Tony and I are a little bit like, we actually stand a chance. If we're not trying to cover the whole area, we might get 0.5. It could happen. Never, ever breach the legal notice. And that has to be automatic and fail-safe. No human intervention required for that to happen at all. The system has to do that. And we have to prove best practicable means for a legal defence and removal of notice. So as well as all the technical people at the client's end, all the engineering, looking at the system, and the chief engineering group, we've also got the station operation people involved, and we've got TfL legal as well. And it was quite an interesting mix of people to have. So what you can see for that, there are two distinct 0.5 STI requirements. And this led to an extensive period of acoustic modelling of various scenarios. The loudspeaker layout that went in 2000 was proven to be optimum and also realisable, but we had to replace the loudspeakers with EN54 equivalents. And the exact model that was in there was less sensitive in its EN54 variant, and so we had to jump manufacturing ships to one that was as sensitive. But other than that, it's exactly the same. We introduced to the client this idea that you might want to equalise your system to optimise its performance. This is a revelation. Absolute revelation. These projects are under such time and budget constraints now. If you say to them, I'd like one night, please, to just go and EQ this, they'll say no. No funds for that. We had to fight over a period of weeks to say, look, this is what the modelling shows. We can improve things by applying equalisation to the voice alarm scenario. It gives us a better or status quo STI, but we get a lower overall level. So what we're looking at here, well, we've got these SPLs on without EQ, and we can reduce those and achieve the same result. And it may not feel like much, but that's a major win to lose 3 dB on the platforms outside when the residence window is here. Okay. Also, it does help it sound a bit nicer. Bearing in mind, they've got these people going around saying, does that sound nice? Yeah, I think it does. So they took that on board and said, yeah, okay, we will allow you time to do that. And so from that point on, the equalisation, having been established for the voice alarm, was then carried over to all the PA scenarios because it was going to be in and it was fixed. We studied 18 designs for just loudspeakers alone. And they were all compared against a control scenario, which is here. Now, operationally, we have a ticket hall, the inside shed platforms, and then the canopy platforms in the cut. They do run those all as one zone. Effectively, we'll announce PA across that because they're dealing with one particular tube line. They will talk about it. There's a walkway up here at higher level, which we'd already convinced them in 2000 shouldn't do PA, and it still doesn't, and it doesn't in the control model either. So what you can see is all these lovely loudspeakers and this lovely smooth coverage. We've got an SPL approaching 87 to 90 dBA under an all-call scenario. And we've got this little dot here. This little dot's really important. Peter's laughing. That's good. I'm glad I made you laugh. That plane is the agreed position for determining whether the notice has been breached or not with the council, between the lawyers. And so we've got an electroacoustic model that's also doing environmental acoustics as well, so it needs to be quite a complex, carefully thought out thing. So we called it the complaint plane. It became known as the notice position. And so the complaint plane can never be more than 60 dBA under any scenario. So with the way they're operating the system at the moment, that's the rating of STI they're going to get for public address, and that's not great. Out of the 18 scenarios, one has moved forward and been installed, so I'll only talk about that one. So what you can see now, if you think back to the other slide that was all a lovely yellow colour, you can see that you're getting areas of intelligibility. The complaint plane is always 60 or under. The SPL in the area is dramatically higher than it was allowed to be before. And there's the magic. You've got 0.5 STI for your PA. And when you actually look at the percentage of the area covered, bearing in mind they were going for 100% before, to just turn on those loudspeakers and achieve 41% coverage in the shed, 52% coverage under the canopies. That's not bad going. So that was why they were happy to go forward with that as an idea and eventually a reality. So we've got compliant STI. What impact does that have on the system? Well, currently, on the system that had gone in, there were already 12 circuits driving those 3 distinct areas. That had to become 30 circuits. Now, 12 was already a big deal because it would have been 6 if it had been done in the traditional way, or maybe even just 4. They'd have never separated the inside from the outside. They'd have just gone on A-B circuit. What are you worried about? So we've now got 30 loudspeaker circuits. That's a major wiring job in a place with very limited cable management running under the platform. But the killer is that the actual shed is allowed to be 5 decibels louder in order to give us some intelligibility, improve signal-to-noise ratio. The reduced number of speakers gives us a reduced direct-reverberant ratio, so we're winning on 2 fronts at this point. So that's why our STI is winning, and we're not breaching the notice. Talk a little bit about ambient noise sensing. We didn't just look at manufacturer's sheets. That is not possible for a project that's as contentious as this. And we were doing a full study, as I explained at the beginning. We invited 3 manufacturers to bring their systems along to a hall for a field test. And we asked them to set their systems up so they were 10 dB over the background noise. And what you can see here is we've got some speakers with a microphone on the top, and every manufacturer followed that, because on this site the only mounting opportunity for the ambient noise sensing microphones was literally on top of the loudspeaker pole, conveniently. And then we've got some other loudspeakers around, and they're doing a background noise. So the background noise was a calibrated recording taken from site of train movements and people coming and going. The message that we were trying to control with the ambient noise sensing was a PA message taken from the site DVA, and we took a load of messages off it, and we found one in particular was the most average of all of the messages that they had on this DVA. And it's the no smoking message, and anyone that was involved in the project never wants to hear that message ever again. And then so the point of doing it in a hall was there was a little bit of reverberation, because acoustics is going to drive this more than anything else. And here we've got 3 systems, and they're tracking. And the important thing really to take away from that is we've got these blue lines here, which Mr. Oliver provided us with. He sat there with the manufacturers and did all of this stuff. That is a 10-second LAEQ. So we're looking really at how far the system is. And if you look at it, they all kind of fall over a little bit, okay? So those were the findings. All the systems require a thorough setup was the first thing. So if the client thought they were just going to buy the kit, turn it on, and everything was going to be magic, we had to say to them, well, no, it's kind of like the EQ. We need a while down there. How long do you need? 2 weeks? What? Yep, that's what we're going to need. They're all an improvement on the offering that we used to have in voice alarm and even pro audio systems, but they're still not perfect. And I think the reality is they're never going to be perfect. I don't think they can be perfect. Only one of those 3 systems that we tested is actually a VA product. The rest are pro audio PA products. But they did all have the ability to limit the upper broadcast level as an ultimate fallback so that you never breach that notice. System with number first. What? I'm actually thinking of getting one of these. I think that would be good. Right. Here is a very basic schematic of what the system looks like. I'm doing a great disservice to the PA engineers that actually designed this by putting this up, but it helps you get your head around the concept, and this is about concepts, okay? We have 2 physical stacks of equipment from the voice alarm manufacturer. One is a PA stack, and one is a VA stack. And you're like, well, why the hell are we doing that? Well, all the PA inputs go into the PA stack. All of the VA inputs go into the VA stack. And what's a VA input? Well, it's a fire mic and an emergency red button, anything from the fire alarm system. The PA would be those lovely SAP units and their DVA buttons, and any other microphones that might be around, or the long line PA that comes from somewhere in Baker Street, and you can't hear it anyway, so who cares? The PA inputs go through the voice alarm manufacturer's PA control stack and then into a PA core, which is a Pro Audio product. And the ambient noise sensing mics for this area of the station go straight into that PA core, okay? So all the processing around the real time is done in here for once. It's also important to note that another reason we need this isn't the only area of the station that we're worrying about. This station is huge. There are other sets of platforms and whatever. Because they're subterranean, they didn't need this funky system. The system they're used to is absolutely fine. The other advantage of using the voice alarm manufacturer's PA input is then all the microphones and things are typical. They're simple for the users. They know what they are. If you started putting a Pro Audio mic in front of them, they probably go, what is that? I don't know. The ANS, obviously, is never allowed to allow the notice to be breached. So in the event that any one ANC, they call it ambient noise compensation, microphone fails, and it's only controlling a small area, but if any one of them fails, we go into complete PA bypass. The VA manufacturer stuff takes over. The level of the PA, any PA messages from any of these PA inputs comes out at a nominal, so quiet level that it's back to where they are now, absolutely pointless. And there is a reason for that. We just thought that they should know on the station that there's a problem. And if they can't hear it or they're wondering what's going on, they'll just realise there's a problem. Of course, they get faults in the normal way because everything is monitored. But if you're standing on a platform and all of a sudden your button goes quiet, you know, oh, well, I've got a problem now. This way, EN54 integrity is maintained. It's fully monitored, as I said. So if there's any fault whatsoever with the Pro PA kit, we go straight into bypass. All faults are reported from the Pro kit to the PA kit, then onto the VA kit, and then onto the building management system, so integrity is maintained there. The mechanism for doing that is everything tried and trusted. We all love straightforward GPI contacts because we can't possibly do anything more funky, can we? The only fault that we can't log is core failure. In the event of core failure, it trips a wire and we go into complete bypass mode, but obviously we can't tell them we failed because we already failed. Both systems have compliant EN54 logs happening, regardless of the fact the PA is just PA, it's still doing it anyway. And as I said, it goes really quiet. And everyone can see it's really obvious. So we have a first. We have a Pro Audio core integrated with EN54 Part 16 voice alarm system with lots of physical wires. I did like it when Jamie mentioned earlier about how elegantly we could do all this in the digital world. Sadly, not quite yet. It's literally copper running between these racks. Every single circuit is coming in out for one and then going back out again. All of our processing is done, and the interesting thing is, obviously, you see, I feel sorry for the VA manufacturers. To pass an EN54 test, your software has to be so restricted and limited. You can't actually do the processing that you can do on a Pro Audio kit. You can't have that many options, which is why it was just more sensible to get all of the potential that we might need. Because don't forget, until the moment that this has actually gone onto the site, and we've been given 4 weeks to bring this system online, all we've got is our modelling, our field tests in other environments. You know, we've got to have enough processing power to make this work and options to do that. Pro Audio ambient noise sensing mics, funky little feature, little LED, so the station can see if it's on or off. Very easy for them to identify when it all goes quiet, who's at fault. The thing about the ANS mics is, normally an intelligent ambient noise sensing VA mic will go straight back to the VA mainframe. We had to put in a VLAN, and this is a first for this client, to actually have audio running around their site, we've got 5 nodes distributed around, and the ambient noise sensing mics are going back to those nodes, and we're bussing information around digitally. Another huge philosophical leap for this client, that you might do digital. They've only just started doing their CCTV digitally, so you start talking about digital audio. But we got there, and that works. And then another first is obviously these SAPs with the pressy buttons and retraining there. The wonderful thing is that this has now set precedent within this particular client, that from now on, when they have a noise-sensitive site, they can actually avoid getting themselves in the mess they got into before and ending up with a court case. They are now identifying noise-sensitive sites, keeping a log going, and the generic of this system has been taken on board as this is the solution, and that will just feed through the engineering teams. If you've got a noise-sensitive site, red flag, use this type of a system, go and speak to these people. So hopefully that's nice. And here's the bazinga. Because the PA manufacturer isn't restricted in what you can do with their software, we were able to work with them and actually turn the ambient noise sensing system into a real-time calibrated noise monitoring system. So currently at that notice position, or up until recently, they had a permanent monitoring position to see. We can now tell them from our own measurements live with PA announcements what's going on. Because the really difficult thing is a microphone from a sound level meter sitting up there. Here's lots of things. And so it's tripping breaches all the time because it's going over 60, over 60, over 60. What's the PA? It doesn't know. It's not connected. Well, this system does, because it's only monitoring the PA system. That is what it's monitoring. We proved that the ANS can never go over the 60 dBA. It took us a while waiting for all the aeroplanes to go past. And that was in the middle of the night. We were all standing up there like, oh, God, here comes another one. We couldn't even get 10 seconds. So, you know, that's interesting. It's been a really long road, as I said earlier, nearly 20 years, waiting for technology to catch up, waiting for the client to catch up. It took kind of a perfect storm to make this happen. But using the process that I've outlined here, and I wanted to get that across, it's not just about the equipment, it's about the process that we had to go through to get to this point. I think we've got there. And I wanted to recognise, I thought this wrapped up quite nicely. Here's a list of the Isc engineers who've contributed to this project. That was something that hit me last night, and I added it in. I was like, you know what? This is very much an institute thing, the more I look at that. So a big thank you to those guys as well. The system, as I say, came online last summer. It's been working absolutely fine. They realised they wanted an extra hotspot, so poor Tony's there next week just measuring the new hotspot. But we modelled it all and made sure it didn't cause a problem. And that, ladies and gentlemen, is it. Thank you. Does anyone want to ask me a question? No.
Ask a question.
Yeah.
Beyond all the science and everything else, the actual people that complained in the first place, how have they, ignoring all the measurements and everything else, what's their actual reaction to it?
Oh, they're complaining more than they ever did. But we can now prove that it's not us that can be causing a problem legally. We knew this was going to happen. We knew this was going to happen, and we told the client and the project and the legal people, you know, that this isn't going to, they're never going to stop complaining. They won't stop complaining. But all we can do is manage it within the context that we've got. We think the reason the complaints increased was obviously there was a month of frantic activity. And you know, Jamie said, we don't go home and listen to test signals, do we? We were inflicting test signals on that locality for 4 weeks straight. So those guys had no option but to listen to our test signals, okay? So they knew something was going on. Now also, with a voice alarm system, I'm sure you're aware that when you can't just take it out and put a new one in, you have to run two side by side. So if they looked into the station, where there was one speaker, now there's two. What's going on? They're supposed to be making it better. So the physical changes were really obvious, and if they hadn't actually gone onto the site, they could see from the site. If they couldn't see from the site, they'd have heard it because they'd been up all night listening to the sine wave. And I think that sort of, inspired people, well, maybe something's going wrong here. But the council are completely satisfied with the solution as it is. And now we're waiting to see if the client's actually got the stomach to go and get the notice removed, which was really the point. Really the point. And technically they should be able to if they've got the stomach for it. Thank you, Neil. But no, that one guy's still there, having a lovely time. Any other questions, Paul?
You mentioned that you'd achieved your STIs by reducing the number of active loudspeakers. Was that specifically within the areas notionally covered by loudspeakers? Or did
Yes,
you manage
absolutely.
Okay.
So I skipped over that because I wasn't sure how interesting that was. Perhaps none of it's interesting, I don't know. I had a slide that I could have put in. So there's poles there and they've all got 4 speakers on. Right. And then you can see that the area we're getting covered is around there. What we did was we told them, here are the extents of the hotspots, and we governed the extents by whether it's 0.5 or not. We're in the driving seat for once, why not? And they were quite happy with that. And they're quite respectable percentages overall of the area. Yeah, and nobody has brought to our attention that there's a problem with where people are saying, I can't hear anything, apart from an area which is under this area here, which was quite interesting actually, because we can't hear anything at the end of that platform under the ticket hall. Yeah, no, but you didn't have a hotspot there. You didn't want one. We showed you. You didn't want one. Well, no, we want one now, because every Tuesday we test the PA, we always put out an announcement, we're about to test the PA, don't do anything, and then they set off the fire alarm. It says, everybody out. And people were waiting there, and every Tuesday people were rushing away because they hadn't had the preceding announcement. Now, there was a really obvious way to deal with that. And I said, well, look, when you make your announcement that you are going to do a test, why don't you do it on the fire mic, because that'll get there. And they were like, no, we want speakers. So there's some rewiring happening this week and measurements next week. But it was all modelled before, and it doesn't affect the plane. The plane we're all worried about, which is actually this one. It doesn't affect it overall. Thank goodness.
That 60 seems a very tough number to meet on a busy interchange in London.
Well, the road traffic's louder than that. Yeah. The planes are louder than that. And we actually went through a study before this that Chris did for us, where we had a monitoring solution up and a system up, and every time the notice was breached, Chris had to go and listen to it. What was it? No, it wasn't the PA. But there's always that thing where when a complaint comes in and they say it was the PA and a breach has happened, you then have to listen to it. And then, how do you separate these things out? You can't, which is why having the system, because it's cognizant of what it's broadcasting, telling you how loud it was and then extrapolating that meant it was that at that plane is just the way forward. Hi.
In the end, was the solution entirely electroacoustic, or were there any acoustic tweaks?
That's a really good point. There was no acoustic allowance at all. When we looked at the things we had to do that I mentioned, such as the covering over of the shed, the noise barrier, all of that was not possible. When we'd already gone through the loop of what can we do to improve the reverberant characteristics of the shed. And it was things, they're very limited, we can put some acoustically absorbing ballast down on the tracks. And I don't really want to do that. Okay, well, the platform itself, it's stone, we could treat that. There's plenty of solutions that are being used in other parts of the world on platforms, that you can make them fairly, or to some extent, absorptive and maintainable, and so that they don't catch fire. But they really weren't into any of that. And the problem was that, for them, they replaced all the platform around the time of the 2000 project. So that's when all the ducts went in, and they were just like, we just can't do that. It goes too far. Even on the adjoining walls between the And that's interesting because the adjoining wall is actually nowhere near the complaint plane. the adjoining wall is here. But that's not where the complaints are coming from anyway anymore. So,
Just have a question. If the regular background noise at the complaint point is greater than the noise from the PA, how much greater? Are we looking at signal-to-noise ratios of sort of -5, -10 dB?
no, it's not that much, Jamie. I mean, it's transiently higher from time to time. If you get a right big rush or somebody speeds past on a Harley down the Warwick Road or a Ferrari, as they're prone to do, or you get a noisy plane coming over at that point. The general background noise, I can't remember what it was. Can you? Mid-50s, yeah.
That's not on a 10-second LEQ, that's on the long range.
Yeah, it's on long range. Correct.
You're also probably getting 5 dB penalty because it's speech rather than...
Oh yeah, no, it had all the penalties applied to it, yeah.
Just a very small point, but on the areas covered, the ticket hall is only 18%.
Yeah.
Bearing in mind from health and safety, I'm jumping guns here, but were they happy with that? Because if
This is a voice alarm. For voice alarm, it's 100%.
Yeah, no, I'm looking at...
For general customer information...
Yeah, I was looking at... If the circle line is closed, you've got all those passengers coming in who haven't heard it, who've gone down the escalator, who now turn around and want to come back up the escalator to try to find an alternative.
Yeah.
I was looking at crowd control.
Yeah. Well, one of the reasons that dictated that this... I'll come back to that. One of the reasons that this is the first hotspot on the platform, there was the potential for another one here. They couldn't allow people to congregate at the bottom of these 2 sets of stairs. Yeah, so that was why that is the first PA hotspot is not quite where you would think it would be on the platform. It's the next one along. And here, this is what they call the paid side of the ticket hall. So their reaction is, you've come through the ticket barrier at this point, they've got to worry about you because they've got to give you information, you're now a passenger. They have staff at the moment and they'll stop you coming in. Or use the outside circuits to say we're closed. Don't come in. So that's why that bit wasn't of too much concern for general messaging.
I've actually done that myself.
Yeah.
I think it was that one. You literally come in, you've gone all the way down to the platform.
Yeah.
It's absolutely packed like sardines, and then somebody's going, no, very sorry, but the circle line's closed. You are then fighting your way back up with everybody trying to come down, and basically it's chaos. But,
Yeah, I think...
But I just thought 18% was a bit low, but then I can understand why, because of the road outside, but...
Yeah, that was what they were happy with there. It seemed to make the most sense to us as well. That's pretty much every speaker on that side of the ticket hall.
If there are visual elements that encourage people to stand in hotspots,
Sorry, they're visual.
visual elements, like signage or something, so people are more likely to be, if they're searching for information, they're more likely to be in a hotspot than...
Yeah, this is where we were saying to them it might be an idea to mark it on, there's plenty of ways of doing that. I tried and trusted this is a listening zone, and they didn't want to do that yet. They might change their mind.
Draw the chalk line around the body at 0.5 STI.
There was a spray line, actually, during commissioning.
How visible are the speakers?
How visible?
Are they integrated in a way that they're almost invisible?
No, they're totally visible.
Totally visible.
Yeah.
So that
I have this
visual cue for somebody to
No, I
get
think-
them.
There's the speaker.
Yeah.
I'm a really, really bad designer. When people say to me, I don't want to see any speakers, I kind of go the other way. And this is an example there of where, because we couldn't hang anything, we haven't got any walls. The only walls we have got are the wrong side of the tracks, literally. We came up with this idea before, and there's just totems with 4 speakers up, and then the canopy is just regular. And there was a little bit of ceiling strut there that was strong enough to just take those speakers, so that's what we used.
People just naturally congregate to the bit they can hear.
Mm.
So if someone's listening to it, someone else comes along and listens as well.
Well, that was the approach they're trying. They just thought that would be enough, that people would just gravitate towards where they could hear. I don't know where that stands as good practice myself. I would have thought you should direct people to a place they could hear, but...
Having worked on lots of stations, that's what happens.
Mm.
you know, if you go to a station that is particularly appalling, that's what the people do.
Yeah. Yeah. A couple of hotspots. I think here, these ones are quite near the heritage visual displays. But I'm not telling you that's by design. That's because my first totem couldn't be there. It's more by luck than judgment, perhaps.
The other thing that, I don't know, obviously there's allowance being made for it, but obviously this looks like a end terminal, is that right?
No.
It's a major interchange.
It's a through station. So has obviously allowance been made for the fact that, you know, where the, obviously the underground trains are, you know, the actual driving train carrier itself significantly louder than the other ones. So.
Well, that's another interesting point, and they did actually address that, and I didn't put it in here because it's not really to do with our project, but one of the things we'd identified back in the day was as they came from underground here and turned, there's a little slight bend into the station, there was a really dodgy rail and it was squeaking a lot, and they did change that rail because that would have been the kind of noise that I don't mind listening to PA particularly, but a squeaky rail outside my window would have just finished me off. I'd had to have moved. Yeah, that's it. But it was particularly bad, and they did find that the rail did need replacing. Doug, you want to ask me something?
Yeah, you know what I'm going to ask.
What are you going to ask?
Did they think about putting any induction loops around those hotspots?
Induction loops on the hotspots.
No. Well, we did bring that up with them, actually. We did bring that up with them. And it was not part of the project remit. I mean, sadly, I know this is a mutual client of ours, Doug, and the attitude recently has been, they don't even want to do design anymore. They're so constricted with budget. They were like, this is nothing to do with it. We've got induction loop around the ticket office windows, that's enough. Yeah, we did talk to them about it, but they haven't done anything. We've told them they're dilatory.
There's a big move in the hearing aid user of society to start advocating and complaining about lack of loops.
Well, I think that's what needs to happen.
Sure, you put the loops not where the hotspots are, and spread the load a bit.
Yeah, but are you discriminating them by not letting them listen where everyone else is listening? You have to be really careful with this stuff.
It's the same message, just different position.
You couldn't just put people steering wheel on deaf.
Yes, exactly. Yeah. It's a sort of form of segregation. Split it up.
You made it!
I made it, yeah.
Hi, welcome.
Through the storm imaging or whatever it was this week. Just a quick one, Helen. Sorry if I missed something at the beginning. But does the system incorporate like a sort of peak limiting type device in the PA stack, such that if you get let's call it an abnormally high ambient level platform side, that your off-site limit of 60 dBA at the receiving location is not exceeded?
Well, yeah, we just have to suffer that in terms of our system and our performance.
It doesn't have a limiting system built into
the ambient. Two things happen, Alex. The ambient noise sensor has a maximum limit set as well as a float. Yeah, to be 10 over. So it can't physically go over that. It just has to ignore those transient peaks should they occur. And the other thing that has improved since 2000 is the AGC that's available in all of the inputs as well. So the biggest issue with that was the live microphones that the station staff were using. With the latest generation VA kit, it's really good at that stuff now, of just rejecting those peaks. So that's what we're doing. We've got quite hard limits happening.
What size are the poles? What height?
What height are the poles?
Yeah.
God, I've got to rewind my brain now. The speakers are at about 3.2 metres, aren't they? Yeah, about 3.5 metres, the centre of the speaker. and the pole's taller than that because, of course, the poles went in originally for PA and have been purloined for other things over time, including now our ambient noise sensors.
Is it possible that you're getting more complaints now because in order to deal with this hard limit, the way it's been expressed to you, you've done things like heavy compression on the input in order to get the maximum level possible and stay within the rules? So now they're actually getting if anything, a harder wall of sound for the same number, if you like, but that's their problem, not yours. But I'm just interested if you think that
Yeah,
might
but I
be the
hadn't
case.
even thought of that. Thought that might be the case. Hadn't even thought of that.
Are you using heavy compression?
Not too heavy, but we. No, not drastic, but there is some.
Is it really slow attacks, sort of more like controlling average level rather than...
We had to do this by trial and error, and I think we ended up with a reasonably fast attack, didn't we, Tony? Yeah, it was pretty fast in the end. Because, yeah, it was quite fast, and calibrating the ANS was great fun. I mean, it took a long time. Because we were even developing the process for doing that while we were doing it. I mean, you can have it all written down in a method statement as much as you like, but once you actually get in the environment, things change. So we did some pre-tests with the manufacturer over in their facility and came up with a rough start. Those parameters went in, and then I'm fairly sure on site the attack was increased. About right, Tony?
Yeah, everything, the ANS is down the limit. It's more limit than the compression.
Yeah.
Oh, right, it's more a limit than compression. I was just going to... So that wouldn't necessarily show up in an STI test, though, would it? In terms of intelligibility?
Well, all this is bypassed for evacuation anyway.
Yeah.
Yeah, one hopes that they wouldn't complain about it.
No.
But they're not allowed to, legally.
Right.
The nuisance cannot exist in the event of an emergency. So, yeah, we do 140 at that point. Let's roll. I wish we could do that with the M54 loudspeakers.
Section number 1, right? Correct me if I'm wrong, but wasn't there a suggestion that by adding compression, you reduced intelligibility? Anybody else hear that?
Yes,
Yes.
It is measurable. So
But all of us are involved in
Articulation.
jobs like this,
Yeah.
where we instinctively, and you are building it into the system, introducing compression and even perhaps limiting at some point. I should have asked the question, but is there some acceptance that it has an adverse effect on STI?
Compression.
Yeah. Because I frowned at that point just as a matter of principle, but didn't raise it.
What are you calling intelligibility? Are you
Now,
calling it STI? Or are you calling it subjective response?
I'm not qualified to.
Yeah, I think there are inherent limitations with the STI metric and what it's actually measuring, okay? And then there's the reality, because we all know that over-compressed audio is not very pleasant. I think with these systems, we're always on a fine line with voice alarm. I'm not talking about the PA stuff now, I'm talking about voice alarm, of getting it loud enough. And so there is a temptation to maybe compress a bit. We're finding, that we try and do limiting rather than compression as far as possible.
I think also Jamie's point was in a sort of hi-fi sense. You know, if you're going to compress, you lose some articulation. Therefore, you're also losing the finer points of speech intelligibility. But if you're struggling for signal to noise, that's small fry compared to what you're achieving with the compression.
it's checks and balances. I think if you do a subjective intelligibility measure on compressed, not necessarily limited speech, it will show a reduction in intelligibility. But and you're right, that may not show up on an STI test because the waveforms are slightly different.
There is some research that says that even if you take it to the extreme and square the waveform right off, that it is still remarkably intelligent.
Yes. You do that for yourself.
But it's not good. It's not nice to listen to it, but you can understand it.
Well, that's always the thing. I mean, that's the double-edged sword between intelligibility and natural sounding. They're often at cross purposes.
18, 20 dB crest factor speech signals.
Use 10.
Yeah, the compression and limiting are unavoidable. In VA scenarios.
As you said, you use limiting, which it makes sense with the noise
Yeah.
one.
Yeah, but also, I mean, with live microphone usage, we have to limit there because people do go for it sometimes. Am I off the hook?
I think so.
Thank you so much for listening to me drone on. I'm changing hats now. Oh, thank you very much for attending that talk. I believe it's probably lunchtime. Thank you all for coming. There is a talk this afternoon by the lovely Martin Bonsoir about audio networking. It's a really good talk. It's one I heard and I was like, please, Martin, come and do it here. So please do come back and listen to Martin later this afternoon. Thank you all very much.